See, the probability of codes getting matched for beginners is really low because you end up using interesting things which are not essential. So people who are experienced, they use a particular structure to solve a problem, and so because of that, it will be, hey, don't worry about that. Okay, I'm telling you, no? So I'm just, but I'm just telling, usually we'll see surprises when beginners code. That's what I meant to say. Okay, so now, so there is, what surprises? Screen not shared. Huh? What surprise? If it is, yeah, that's the point, right? You don't know what you get surprised with. So that's why I don't know. Anyway, so one so there is one small logic. So before we start assignment 3, you take a read the problems and start working, whichever you feel is easy. But don't you think the problems are fun? Assignment 3 problems. Yeah, so you should enjoy. Okay, so it's see, usually people, if you do solve these problems, you get exposure to many cool ideas. Okay, so we'll no, don't worry. So you start with what is pretty print. I think it's being asked in some other in the other session also. It's like, for example, yesterday we talked about, you can read a polynomial, like for example, the polynomial is 2x cube plus 4x plus 2. So you can give the input as degree 3. This is degree and coefficient 2, degree 1, coefficient 4, degree 0, coefficient 2. So these are degree, and this is coefficient. So pretty print is simply you print on the screen 2 times x cube plus 4 times x. You just print the same polynomial on the screen, nicely formatted. That's also that. Okay. Are you with me on the pretty print part? Don't use xxx. No, this is not good. Is that how you write in Is that how you write xxx, the polynomial? No, no. What if it is that the polynomial is x power 20? I don't want to give the input-output format before itself. You use your input-output format. Okay, later on you kind of spend some time to massage and change it. Okay. Okay, let's go ahead. So now the problem that we would like to discuss in today's class, we'll start with the swap problem. So in a program, so we want to write a program. So let's start with a program. So our goal is to write a program to swap 2 numbers. Okay. So there are two variables, var a, which is initialized to 10, and var b, which is initialized to 20, and printf var a is equal to %d, var b is equal to %d. And after swap, this is what we have. And so now we want to write code here in between. No? So code to swap the contents of var a and var b. This is what we would like to write here. Now, if you just compile this program, gcc swap.c and .a.out. So, yeah, all the time I make this mistake. So right now there is no swap happening, and we want to swap the contents of the two variables. So this necessity to swap the contents of two variables you will encounter when you are working with on sorting algorithms. Yeah. In next week, perhaps we'll study a bit about sorting algorithms. Then you will see that learning this logic comes in handy. So here, in order to arrive at this logic, let's say you have two beakers or two glass tumblers. This is tumbler A and this is tumbler B. If you want to swap the contents of these two tumblers, what do we do? If we have to swap, A contains milk and B contains water. Okay. So what do we do? So this A contains milk. So you use an intermediate holder. Okay, let's call it as T. So what is step 1? What is step 1? So we transfer the contents of A to T. This is step 1. And what is step 2? Transfer the contents of B to A. That is step 2. And what is step 3? Transfer the contents of T to B. Step 3. This is the logic. This is how we can transfer the contents of exchange the contents of two beakers. So what is the equivalent logic here? Step 1 is transfer the contents of beaker A into some temporary, and so we have to first we need to have a temporary variable, and then so this is A. And what is step 2 is var A is equal to var B. Step 3 is var B is equal to 10. Okay, so that's all. Does this make sense? You're all with me? Easy, right? So now when you compile this program, gcc swap.c, and when you run this program, now you will see that the contents of the two variables have changed. Okay. So now we want to slightly modify this program because usually you keep using swap again and again and again. So you want to create a function out of this swap program. So we want to define a swap function, and now the question for you is, will this logic work? Why wouldn't this logic work? Okay, so that's the question. So now, so here we say swap var A, var B, so in order to understand what is happening here, why this wouldn't work, so this code, we will go through this code carefully and see what happens. Okay, so you can see that this code is not working, that var A and var B code is not working, and the particular way we have written the swap function, it's not working. So let's try to understand, so what is exactly happening here through by GDBing this program. So GCC minus G swap.c. In order to understand this, oh, I didn't put any breakpoint. Okay, so let's put a breakpoint on swap. And run the program. GUI enable. So one important thing I want you to observe, pay attention here, is underneath this program, if you look at this program, your program, let's look at a simplified main memory layout of your program. This is the main memory layout, and in the main memory layout, I'm saying this is simplified. There is a part where the actual code will be present. Like for example, here you have two functions. So one function is main, and another function is swap. We have two functions. So when you give the program, so there is this question from the other section. So the instructions of the program are supposed to be on the hard disk, right? Then why are you showing it in the RAM? So what's the answer for that? The instructions, when you compile the program, a.out got created, right? When you give the program for execution, the instructions that are present in the a.out will be loaded into the RAM. Perfect, very good. So now what happens is, I will show you one interesting command, backtrace. BT stands for backtrace. You see that on line number, this is what is called as a program stack. When you do BT, GDB shows what is called as a program stack. All right. And yeah, so there's a BT stands for backtrace. So no, when I teach back to back two sections, I face some issues. Okay. So case one, when the particular flow of lecture happens very nicely for section A, for example, then I will try to repeat that flow, but no, that naturality wouldn't be there. So I will be trying to recall what I did in section A, and it wouldn't quite nicely pan out sometimes. Because the second case is when I don't do well in section A, then what happens is I figure out a way to fix it for section B. So for section B students, it goes both ways. Sometimes it wouldn't be fun, sometimes it would be fun. Anyways, so, but these problems would be solved if we have one section, but one section would be too big. Okay. Anyway, so let's say different thing. So what happens is right now, before like on line number 18, I have a question for you. On line number, no, before we call the swap function, while it is part of the code, while it is part of the code, it gets active only when it is called. Yes or no? The code is there, it's not active, it gets active only when it is called. That's a first observation. The swap function becomes active only when it is called. And after the swap function gets executed, when you are out of it, it is again no longer active. It is like the swap function, it is there, it becomes alive for a period of time, and after that again we are out of it, and again no, it kind of is not alive. All right. So now, what are the functions that are active? Is main function active now? We are on line number 7. Is main function active? Main function is still active, no? Main is calling swap. So main is active, and when swap is called, so swap is also active. So what happens is, if you look at the main function, this is there is what is called as an activation record for main function. So in the activation record for the main function, so there is memory, this is var A variable, and this is var B variable, and this is what is called as an activation record. Of main. Are you with me? This var A and var B, this is the memory for var A and var B. Activation record, RECORD record, activation record. In the activation record for main, the memory for var A and var B will be allocated. Now, when swap is called, the activation record for swap will also be created, and there are 3 variables. Okay, so A, B, and temp. This is the activation record. I am using a shorthand swap underscore AR to indicate that this is the activation records for swap. And this is what is called as a program stack. The program stack that we are talking. Stack means it's like it's a stack which is growing in the opposite direction. Okay, this is a stack. This is the program stack. Usually, when we go to a restaurant, we will So when we go to a restaurant, we'll have a stack of parathas on a buffet, and you always access the paratha on the top, right? Last in, first out. So here, this is a program stack, but it is, in this particular case, we are drawing the program stack in an opposite direction. Okay, if it is a stack of parathas in the opposite direction, the parathas will fall down, but here, the activation record for swap is not going to fall down. Okay, it's a logical thing. Are you with me here that the activation record associated with a function, it contains many things, but among them, the important thing is the memory that is allocated. Memory is allocated to the variables of the function in the activation record. So now, if you see, let's see, what is the content of the variable a here? This is equal to 10, right? Stack means usually we think it grows in the upward direction, right? But here it is good. So the activation record for swap is pushed on the top of the activation record for main, but it's a kind of downward stack, downward facing stack, because it's not growing up, that's all. Think of just a stack of parathas, okay? So this, the first paratha is, now we are calling it as the activation record for main. The second paratha, we are calling it as the activation record for the swap function. Are you all with me here? This one. So number one in the, so just anyway, so forget about stack and all that, just pay attention to me once. So in main, what is the value of var a? 10. Var b is equal to 20. And the memory for var a and var a b is allocated in this space, in the activation record associated with main. Are you with me on the first point on this? Yes or no? Now when swap is called, what happens? Since we are doing call by value, the value var a is copied into the memory location associated with capital A variable, and it is, so this gets copied to here and this gets copied to here. Are you fine with this? This is because we are doing call by value. This is call by value. So now when we execute, temp is equal to a on line number 7, what happens to temp? Temp becomes equal to 10. That is what happens. Now when b is equal to a, on line number 8, what happens to the contents of variable a? The new value of variable a, it gets transformed to 20. Okay. And then when we do next, yeah, that's what. And then after that, b is equal to temp. So what happens to the contents of variable b? It becomes equal to 10. Is anything happening to variable a and b of the function main? Are we touching var a and var b of function main? It's not happening. So all the swap is happening. No, swap is working on the variables a, b, and temp, which are within the local values. Okay. So because of that, swap is not working. So there is no binding between var a and capital A and var b and capital B variable within swap function. There is no. Focus on what I'm telling guys. Okay, so are you all with me here? So the activation record for, forget about returning, just understand what the argument, then the argument that is being presented, do you understand? Oh, that's we didn't still execute it. So what happens is we are not changing the state of main. And if you want to have a bit more fun, okay, I don't want to. So I'll show you something, and if you don't quite get it, ignore it. Okay. So when we do up no in GDB, we are going back one level above in this stack and checking. Now we are in main, and when we do print var a, it is still 10. Are you with me here? The up command in the stack, in the activation record, we are telling GDB to go one level above and examine the stack of the activation record associated with main. And it so turns out up doesn't change. The stack will be the same. You will no, it's like you are entering a different room. Up is like, you're going one floor above and checking. So up is like this. So here, if you see, this is all from GDB. Up is you go one level above the floor, and so right now let me do one thing. Use a different color. Maybe use this. So earlier we are here. This is the current stack. When we do an up, we go here, the up operation. We'll go to this one and examine that. That's all. And then we want, but this is not the correct state, right? So correct state means the current. Right now we are in the function swap. So when we do down, we are again back to the floor. Okay, this is just for examining purposes. Okay, so now we are in the. Now we cannot print var a because var a is not available for us. Var a is available only when we go one level above in the stack. Are you all doing okay? Hey, don't worry about it. Okay, so just no. So I don't want to get into. Take a deep breath, and I focus on only one thing. I'll reset and number one. So where is the memory allocated for var a and var b of function main? Just tell me that. Ask activation record associated with the function main. Activation record of main. Now, when we call swap, what happens? When we call the function swap from main, what happens? When we call function swap from, good. So when we call function swap from main on line number 19, what happens is the activation record for swap gets created. Excellent. Swap underscore AR gets generated. And what does swap underscore AR contains? Swap activation record for swap. What does it contain? It contains the memory for A, B, and temp. Now, when you do the swap, when you execute the instructions of the swap function, the contents of the variables A and B are modified or swapped, but the original var A and var B, they are the same. Are you all with me till this point? Okay, so if you understood this, you are good. That's all. Okay. Don't worry about BT. Okay, so you try to figure out BT by yourselves. BT is, it just shows the what is yeah, because you can see the trace now. That's what we did. The A and B are only changed in here, but they are not var A and var B. They are not changed. There is no link between var A and the variable A. There is no link between var B and the variable B. In call by reference parameter passing mechanism, what happens is there will be a link between the variable A and var A and the variable B and var B. Any changes that you make to A and B, they gets reflected in var A and var B. That is in call by reference parameter passing mechanism. But we don't have that in C programming language. Yeah, that's true. There is no call by reference. If at all there is a call by reference, that would be the semantics, but there is no call by reference in C programming language. Okay. So now can we try to fix this program and see how it pans out? Okay. Now let's. Yeah, now when you are out of function swap, the memory that is allocated to A, the variables A, B, and temp, they are deallocated. They will no longer be there. Okay. I want you to understand this. Okay. So now, so we are on line number 10, right? So now when we say, what will be the activation record? And if you look at the activation record for swap is no longer there because swap is not active. Does this make sense? Because swap is not active, so we don't need memory for the variables A, B, and temp. All good till this point? Okay. So now let's try to fix this program. And the way to fix this program is by using pointers. I want you to understand, just because we are using pointers doesn't mean that we are using call by reference. We are still using call by value only. Let's see if this works. Now you can see that they are swapped. Okay, it is working when we are. So now let's see why this code works. Now let's try to understand why this code works. Okay, so let's compile this GCC. So how do we understand? We want to use GDB and understand what's going on. Break main, break swap, run. Yeah. So now what I would like you to observe is what is the address of variable A and what is the address of variable B. So let's draw the memory map again. This is the memory map. Keep your questions, I'll answer them later. I want you to follow a particular line of thinking here. So here the code for main and the code for swap. This is the code. Now, what is the activation record? What is the program stack contain? We are in main. Does the program stack contain the activation record for swap? Does the program stack contain the activation record for main? Yes. So now, if you see the state of the program stack, so this is var A, this is var B. What is the address here? This is 300. It is 304. Okay. Fine with this. This is the state of the activation record for main. Are you okay with this observation? Main underscore AR. Now let's continue. Now, if you see, do a BT, then you will see that the program stack now contains the activation record for swap also. What does the variable A contain? What does the variable A contain? Sorry. A contains 300. And what does B contain? 304. Okay. You're all with me so far? So now when we say temp is equal to star A on line number 7, what happens? This is 10, this is 20. When we say temp is equal to star A, this temp, so star A is, what does star A means? Go to the memory location 300 and from that read. So when we execute line number, so this gets copied here and this becomes equal to 10. Right? Good, na? Are you fine with this? Now when we say star A is equal to star B, what happens? Which memory location gets changed? The memory location 300 gets changed. The memory location 300 gets changed. And what happens is this will be overwritten. This will be overwritten. And what do we have here? We will have 20. I hope everyone is with me here. What if we have A is equal to star B? Instead of star A is equal to star B, if we have A is equal to star B, what happens? If you have A is equal to star B, then this memory location gets changed. This one gets changed to 20. You don't get segmentation error at this point, but the memory location associated with A, the 300 will be overwritten and you put 20 there. Okay. So now let's keep going. Value of A doesn't change. Value of, if A is equal to something, if A is equal to star B, then the value of A will change. But when you say star A is equal to star B, the value of A doesn't change. Just follow the thread. Now when we say star B is equal to temp, what happens? When we say star B is equal to temp, then the address 304 gets overwritten. And this will be equal to 10. Great. So now the question for you, did A and B change? This is the question. Did A and B change? A and B didn't change. Did var A and var B change? It changed, got swapped. And did we use call by value parameter passing mechanism or call by reference? We just use call by value only. There is nothing like call by reference. Okay. And that's all. Okay. This is how the story, kind of we get around, the net effect, we want to change, manipulate var A and var B. For that, we want to pass the parameters, their addresses. And in order to pass the addresses, we need to use pointers. Akshat, don't worry about it. So there are optimizations. They may or may not be contiguous, but it will still, there could be some gaps, but it will be, the activation record will be contiguous only. Are you all with me here on this one? Now I have one interesting question. There is, so when we usually pass a return value, return temp, for example, when we have something like this return temp, so what happens is this return value, there is in the processor, there are ways of handling this, but in the processor, you will have a register file. Like, and there could be a register, like for example, EAX register. And let's say if temp contains 10, that return value is present in this register. And the function calling the swap can either look at the return value if it wants, or it can ignore. Like for example, printf has a return value, but we are ignoring it. But in case if you want to check the return value from printf, you have to use a variable and you just have to go and look into the register. Okay. Are you with me here? How return values are handled? That, and there are other ways of doing it also, but this is one particular way of doing it is you pass the return value through a register in the register file. We cannot have two register. Register is not in the RAM, it is part of the CPU processor. We have a register file in the processor. Registers are not in cache memory. So register file is in CPU, is in the processor. If this is your processor, there will be what is called as a register file. This is your CPU. There is what is called as a register file. The return values, there are many ways of returning values. One way of returning value from a function is via register file. That's all. And when a value is returned, it's up to you whether you want to use the value or not, ignore the value. For printf, many times we ignore the value. Are you with me here? Approximately. I'm not expecting a complete understanding, but a little bit on the return value also I thought I'll use this opportunity to share. But more important than this is can you show register? Huh? How can you show registers? Yeah, like for example, here, these are the registers in the processor. They are the contents. EAX is the name of a register. So just don't worry about it. Okay. So here you can see that register is named RAX. These are the registers you will learn about this in your computer systems organization course. But for the time being, just this much understanding is good enough for you. Okay. More interesting question is, let's say by some mechanism, the registers, the return values are passed, but I want you to focus on this question. On line number 12, now I am returning the address of temp. Does this work? Can you do? Is this all right to return the address of temp? Why is it not all right to? Int star should be the return type. Huh? Okay. But I can do typecasting. Int, what happens is in C, I can just typecast it. That's not the problem. But Vinkesh got it. When we are out of the swap, the memory that is allocated to temp is no longer there. So it's useless, that memory location, if you go and change, then the program semantics is not assured. Things can go bad for you and your program can crash. Because once you are out of swap, the memory that is allocated for the variables A, B, and temp on the activation record, they are deallocated. So there is no point in using that address. Are you with me? It's like giving the address of a person who vacated a hostel or a house. And if you go and look at that address, what will happen? Someone gave an address of a person who left. Syntactically correct, semantically wrong. And that person has left that home. What will happen if you go and look? If you go and look, sneak in, why someone else is there now, then they can punch your face for sneaking in. So be careful. So if you return temp, what happens? The value that is there will be returned. Whether we return or not, it doesn't matter. We cannot have two returns. We can return only one value. What if temp is a global variable? That story is different. Good question, Straits. Okay, I'm just using this to show an example. That I think you need to understand. The memory is not allocated. The memory for temp is gone once you're out of swap. Exit means you exit from the program. Swap, return means you return from swap and come back to main. You can call a function from any other function, nothing like that. If you write exit in swap, you exit from the program. We cannot do swap without a pointer. How many of you understood? Let me get the last point on the temp. See, when you are out of swap, is memory for the variables A, B, and temp allocated? Is it there or not? Then what do you do with that address? That's the only point. You are returning the address of temp, but it is not useful for you because the associated memory is no longer there for swap. So it's useless. It's garbage. The address of temp after you are out of swap is a garbage value. You should not use it. That's it. Your friend is gone. Your friend vacated a room. And why do you still want to go there and hang around? Register, leave it. So don't worry. This much I want you to understand line 11 because you will end up making mistakes. If you return temp the value, so this is the question. if you return temp like this, it is like this, okay? So there is a difference between returning temp and returning address of temp, okay? So similar question is asked in section A. So returning temp, no, let's say there is an apple, and no, so returning temp is the value you are giving. You are giving an apple and you can use the apple, eat whatever you want. But instead, let's say there's an apple which is in a house, and if someone gives, before vacating, someone gives that apple to you, you can use that apple, eat whatever you want to do. But instead, no, if someone, instead of giving the apple, if they give you the address of that house in which that apple is present, when you go and check, what happens? Instead of apple, you may find orange. Yes or no? So returning a value is like giving the apple present in the house to you. You can use it for whatever purpose you want to use. But returning the address of the house in which the apple is present, it's bad, because you go look into that house. No, instead of apple, you may find orange, or you may find, anaconda or whatever. So we'll go armed. That's true when we are out of main, vary and varby are also deallocated. Why orange when apple is present in the house? But someone else who occupied that house wants an orange, not apple. Right. I didn't get your question, Nikita. What is the significance of what? Why should someone return the address of, like, why to write? I'm just trying to, there's a conceptual thing that I am trying to teach you, okay? So when you make an error, you make, you will learn it in the hard way, but when you are out of mean, the memory for vary and varby will also be deallocated. See, as computer scientists, you need to know inside out of stuff, okay? Just not learn how to write programs. There will be no problem here. There is no way to return multiple values. The only way is you have to declare, construct what is called as a structure, and then do it. Lunchtime. Yeah. I never like to use functions other while doing. No, you have to use functions, guys. There is no array. I keep changing code to illustrate different points. So, if we return, it will be stored in some register. Okay, I think I will stop here. I want you to think. See, how do we access a return value? It's just very simple, na? Retrval. You don't need to do it. You just have to use, compiler will do it for you. You just say retrval is equal to printf. Where can we study what? I think I'll stop here recording.